Good afternoon to all. Today we are going to discuss about the avionics. Myself, Kasiviswanthan, Assistant Professor, Aeronautical Department, PSN College of Engineering and Technology. So today we are going to see about basic introduction to avionics system. Right. So introduction to avionics. First of all, what is avionics? Avionics is a combination of aviation and electronic systems commonly used in aircraft and other electronic systems. It also defines as electronics in aerospace application. Initially, avionics was commonly used in United States of America in the early 1950s. Right? The avionics industry is nowadays become a major multi-billion dollar industry throughout over the worldwide. Some of the examples for avionics industries in India are Aviation India at New Delhi, Tal Aviation, Taneja Aerospace Limited, Rajamsa Ultra Highlights at Bangalore, and also Data Pattern. These are also some of the most popular companies for avionics systems. So these are the general introduction terms about avionics. So now let us see the need for avionics systems. So what is the need? Avionics systems are essential to enable the flight crew to carry out the aircraft mission safely and efficiently. So this is the first and foremost need for avionics systems. So in aircraft, usually civil aircraft and military aircraft are commonly using. So let us see the difference between the civil as well as military aircraft systems in which the avionics systems are used. In civil aircraft, the major purpose of the mission is to carry on the passenger to their particular destination safely and securely. So this is a major purpose for civil aircraft in avionics system and their applications. Example, civil airliners, passenger aircraft, lot of aircrafts are there. Also in military aircraft, to carry out the military operations and other security services. Right? So these are some of the commonly used points for the need for avionics systems in military aircraft. Intercepting a hostile aircraft, that is one case. Attacking the ground target, another one, and that is last one, maritime patrol. Similarly, in spacecraft, the major purpose is to carry the mission safely because of the reduction in weight and long lifetime mission. These are all some of the most important need for avionics system. Okay. Next one, common advantages for avionics system. The same case, civil aircraft as well as military aircraft. So some of the commonly used advantages are the applications and advantages in the sense minimum flight crew. Commonly we call it as first and second pilot. Similarly, saving of crew salary, reduction in weight that can be translated into more passengers or long range flight time on less fuel. Similarly, reduction in maintenance costs. So as far as military aircraft is concerned, a single-seater fighter is enough, and so cost less than an equivalent two-seat version, reduction in training costs, and also the reduction in weight. So these are some of the advantages of avionics system. Okay. Very most important advantages for the avionics system in the sense major functioning system is for increased safety, air traffic control requirements, then weather operations, in fuel consumption, that is reduction in fuel consumption, improved aircraft performance and control, and handling and reduction in maintenance costs. So these are the most important advantages for the particular avionics system. Whereas in the military cases, the avionics systems are also being driven by a continuing increase in the threats which are possessed by the offensive and defensive capabilities of potential aggressors. So these are the common advantages and these are very important, right? So next one is integrated avionics system. What is meant by integrated avionics system? Integration. Commonly abbreviated as IAS is a common abbreviation term for integrated avionics system. This is a combination of various systems as well as subsystems which interconnect to the data buses and then combining to form a single system. This is called integration in general. So commonly types of integrated avionics systems are classified as cockpit control system, sensors integration system, control integration system. So these are the commonly used types of IAS, that is integrated avionics systems. Let us see one by one. First one is cockpit integration system. So cockpit integration system, it consists and involves the following display technology and control. So what are all the technologies nowadays we are using? These are all the various technologies implemented and the latest technologies has been implemented now. Cathode ray tube, we all know CRT tube, and LCD panel, liquid crystal display. Similarly, HUD is head up display. HMD, helmet mounted display. So these are all the cockpit system integration display systems. The major problem is the limited amount of instrument panel available in aircraft. One which is particularly acute in combat aircraft where panel space is severely a limited one. So this one is some of the constraints for the cockpit integration system. So let's move on to the sensor integration system. So second one, sensor integration system. The sensor integration not only reduces pilot workload, but it also expands the past coverage and increases the confidence level in target existence and identification. And it is mutually supportive one. So these are the main important highlights of sensor integration system. Another one, sensor fusion is an art of combining the various target data sources automatically and presenting the pilot with a unified and complete tactical picture within all the ambiguities resolved. So these are some of the highlights and highlighted information points for sensor integration system. This one is the sensor fusion. So this sensor fusion produces a robust system that is difficult to jam because all the elements are mutually supportive one. So through this sensor fusion system can produce a robust system, but it is difficult to jam because of all these various elements are mutually supportive, one-to-one correspondence, right? Third one, control system integration or control integration system. So integration of aircraft control function offers more significant benefits. The autopilot and flight management system grouped together to reduce the pilot workload. The major responsibility for them is to reduce the pilot workload and enables the fuel-saving flight profiles to be flows accurately and consistently. So this is the main important part of the control system function. Engine control integrated with flight control. So these control system allows the engine measurement system to anticipate aircraft maneuvers and reduce the artificial margin currently imposed to ensure that engine operating limits are not overstepped in cockpit. So these are all the control system integration functionalities which we are carrying out in the avionics systems as well as in the subsystems. So this pictorial representation shows the integrated avionics system. So you can see different components and processor or control unit, major portion for carrying out the operations. And then antennas, input data for keyboard entering, then display output devices. Then for navigation purposes, we are incorporating GPS, that is global positioning system, and terminal for connecting purposes. So these are all the various subsystems combined together in order to form a integrated avionics component system. Next one, integrated avionics weapon system. Once again, so integrated avionics weapon systems generally composed of various instruments: sonar, radar, communication system, EOS, electro-optic system, ECM, electronic countermeasure, ESM, static measurement, status indication, right? So these are the different components of integrated avionics weapon system commonly used in aircraft warfare and other purposes. So let us see one by one. So first one is sonar. Sonar, the exact abbreviation is, we all know, sound navigation and ranging. Sonar denotes sound navigation and ranging. It's a technique that uses the sound waves, sound propagation, commonly used in underwater areas and in submarine navigation system to navigate, communicate with or detect objects under the surface, under the water surface, such as submarines and other vessels. So these are the main function of sonar, to detect the uses sound propagation to navigate. So it's commonly used under water surfaces. Here the two types of technology as the name sonar, that is passive sonar, similarly active sonar. So passive sonar, listening for the sound made by the vessel. This is the functional part of a passive sonar. Similarly, active sonar, it emits pulses of sounds and listening for echoes. So these are the two comparative statements for passive sonar and active sonar. So once again I am repeating, passive sonar is especially essential listening for the sound made by the vessels, whereas the active sonar is emitting pulses of sounds and listening for echoes. Here, the sonar may be used as a means of acoustic location and of measurement of the echo characteristics of targets under the water. acoustic location in air was used before the introduction of radar. So before radar introduction, these type of instruments can be commonly used for detection purposes. Okay. Here the sonar may also be used here for robot navigation and SODA, another one part, that is sound detection and ranging. And sonar is sound navigation and ranging. Here the SODA is sound detection and ranging. Is used for commonly atmospheric investigation. The term sonar is also used for equipment used to generate as well as the receiving of sound noises. The acoustic frequencies used in sonar system vary from infrasonic to very ultrasonic. So the study of underwater sound system is known as underacoustics or hydroacoustic system. So here the frequencies which we are used is very important. Very low frequency to extremely high, that is infrasonic to ultrasonic. The study of underwater sound is commonly known as the underacoustics or hydroacoustics. Hydro, it's already known, means the water. Okay, let us see the frequency range. Here, the high frequency active sonars operate between approximately 30,000 and 5 lakh hertz. That is, in terms of kilohertz, we can put it as 30 kilohertz and 500 kilohertz. So these are the operating frequency range for active sonars. So here, these systems allow increasingly greater resolution as frequency increases, but at the expense of ranges. So here the frequency of this part is the most important one, 30k kilohertz and 500 kilohertz. So let us see the application of sonars in aircraft. So commonly helicopters can be used for anti-submarine warfare. In warfare, we are using these systems for deploying fields of the active or passive sonobuoys. Or they can operate dipping sonar such as AQS-13 series. Similarly, fixed-wing aircraft type can also deploy sonobuoys and have greater endurance and capacity to deploy them. So here in this, we are also using the fixed-wing aircraft type for deployment purposes. So deployment purposes, we are using these categories aircraft. And processing from the sonobuoys or dipping sonar can be on the aircraft or on ships. And also helicopters have also been used for countermeasure mission using towards sonars such as AQS 2A series. So these are all some of the different parts or areas in which the sonars can be used. Second one is the radar. As we all know, radar acronym for radar is radio detection and ranging. Here we are using the radio signals, radio frequency. So radar is an object detection system which uses radio waves to determine the range, altitude, direction or speed of the objects. For all these applications we are using the radar. So radar can be used to detect the aircraft location, position or altitude and determination. Not only aircraft, ships, spacecraft, whereas guided missiles, vehicles, and similarly for weather information as well as mountain terraneous regions. So all these areas, the radars are commonly used. So the radar dish or antenna in general, we are speaking about. The radar dish or antenna transmit the different pulses of radio waves or microwaves which bounce off any object in their path. So these are the working concept in which the radar dishes as well as antenna in generally transmit the pulses of radio waves or microwaves which bounces off any object in their path. The object returns a tiny part of the wave's energy to a dish or antenna, which is commonly located at the same site as well as the transmitter. Here, the connection wise, in the sense, we are using duplex communication. Duplex in the sense two-way communication. So, all the information transmitted as well as received, and all these informations can be retrieved. These are the general history of radar. Radar was secretly developed by several nations before and during the World War II. The term radar was coined in 1945 by the United States Navy as the acronym for radio reduction and ranging. This radio reduction and ranging acronym denoted by the US Department of Navy, United States Department of Navy. So similarly, other systems similar to radar make use of this electromagnetic spectrum, EMS. Another one example is LIDAR, which uses visible light from the lasers rather than the radio waves. So these are the common functionalities for radar. Okay, now let us see the applications of radar. Commonly, radar used for detection purpose, target detection and estimation purpose. The first use of radar was for military purposes to locate air, ground as well as sea target. Right? These concepts evolved in the civilian field into applications for aircraft, ships and routes. In aviation, aircraft are equipped with radar devices that warns of obstacles in or approaching their path and give accurate altitude readings. So these are the common historical areas. The first commercial device fitted into aircraft was a 1938 Bell Lab unit on some United Airlines aircraft, in which the radar was first incorporated. So this type of aircraft can land in fog at airports equipped with radar assisted ground control approach system, that is GCA, ground control approach system, in which the plane's flight is observed on radar screens while operators radio landing directions to the pilot. So some of the military communications system, avionics system. So reviewing the history, the first military communications had the form of sending as well as receiving simple signals. Suppose if you are transmitting one signal and similarly if you are receiving the signal from the transmitter side, so it will be some that is noise or some other unwanted disturbances which will be created. So respectively, the first distinctive tactics of military communications are called signals, while unit specialization in those tactics received the signal corps. So from that itself only the word signals has been derived. Later signals and signaler become a highly distinct military occupation, dealing rather with general communications methods than with weapons. Nowadays, present-day militaries of an informational society, it conducts very intense and complicated communicating activities on a daily basis by using the modern high technology, telecommunication and computing methodology, tools and instruments. So only a small part of these activities is immediately related to the combat actions for warfare. That's why some of the term preferable as military communications. So military communication in the sense it's the communications commonly used in warfare and other defense self-operations. So modern concepts of network-centric warfare, that is commonly called as NCW, which relies on network-oriented methods of communications and control technology to make the existing forces vastly and more effective manner. Okay, next we move on to the EOS, that is electro-optics flare, FLIR, forward-looking infrared radiation range. So this EOS concept, electro-optics, is a general branch of technology which involves components, devices and systems which generally operates by the modification of the optical properties of a material by means of electric field. So this is how this EOS works. Thus, it concerns the common interaction between the electromagnetic such as optical and the electrical states of materials. Though radar is an effective sensor, particularly in its advanced form, it has a fundamental weakness in general as it requires that the transmitter which illuminates the target with energy. These are the common requirements and weakness for these sensor systems. Right? So while doing it so, it identifies itself and betrays its locations, not to speak of its vulnerability to deceptive or other ECM, that is electronic countermeasures. Electro-optical, that is EO sensors on the other hand, do not have these deficiencies as they are entirely passive, sensing energy emitted by or reflected of the target itself. When compared to radar, these EO systems are really newcomers to the field of war. The first serious application in general commonly being the use of FLR, forward-looking infrared system, during the Vietnam War to provide gunship crews with night vision. During those times, these FLIR systems has been incorporated. So it proved to be a great success. Enemy personnel and equipment betraying their location with their own heat emissions. So for that purpose, they have been already implemented and tested. So this lead to a substantial increase in the development, yielding a broad family of FLIR system by the late 70s. Vietnam also saw to the development of another family of EO system, that is the stabilized TV telescope. So this is one important system which has been used in olden days during the Vietnam War. So one of the basic aspects of the air war over Hanoi was a necessity to visually identify the hostiles prior to weapon launch. Right? That is a very national approach bearing in mind the low reliability of IFF, that is identification friend foe, which can be used as a systems as used at the particular time. Okay, let us move on to the electronic countermeasure, that is ECM. Okay. What is this ECM do? This ECM, an electronic countermeasure, is an electrical or electronic device specifically designed to trick or deceive radar, sonar, or other detection system like infrared or lasers. So for that purpose, we are using this ECM part. It may be used both offensively and defensively to deny the targeting information to an enemy. The system make many separate targets appear to the enemy or make the real target appear to disappear or move about a random manner. So these are all the common terms or common points to be incorporated for the electronic countermeasure such as ECM. Similarly, it is used effectively to protect the aircraft from guided missile. Most air forces use ECM in order to protect their aircraft from the different attacks. For that purpose, we are using these electronic countermeasures. It has also been deployed by military ships and on recently some of the advanced tanks to fool laser or IR guided missiles. This is where the ECM is commonly used. It is frequently coupled with stealth advances so that the ECM systems does an easier job. These offensive ECM systems often takes the form of jamming, that is incorporated cutting off signals. So the defensive ECM includes using blip enhancement and jamming of missile terminal homers. For that purpose, this offensive as well as defensive ECM has been used. The avionics system or its subsystem in general means any system in the aircraft which is commonly dependent on electronics for its operation. Right? So, because 30% of the total cost occupies these electronic systems. Total cost of the aircraft. Suppose the aircraft costs approximately around 1,000 crores. The electronic component, which constitutes 30% of the total cost. In general, data says avionics equipments can account for 30% of the total cost. Similarly, suppose if it is in the case of maritime patrol or anti-submarine aircraft, the percentage constitute is 40%. And also in case of airborne early warning aircraft, that is AWACS, airborne warning and control system, aircraft control system, which constitute around 75% of the total cost of the aircraft. Then you people imagine how the functional aircraft components are there in the physically presented in the aircraft. Okay. Next one, let us see about the subsystem. So subsystems in the sense, the system which interface directly with the pilot. Second one, different sensors such as the aircraft state sensors. Third one, navigation system. And fourth one, external world sensors. The last one, task automation management system. So these are only some of the subsystem of a avionics system. Let us see one by one. So before going to discuss, let us see the block diagram of the avionics system. So these are only some of the components. Here, different actions to be performed, such as displays, communication, data entry and control, FCS, that is flight control system. These are all constitute one part in order to communicate with the pilot and to the ground station, whereas from the ground station to the pilot. So displays, communication, data entry and control, flight control system plays a very, very important role in avionics system. Then Let us see the second category, aircraft state sensors. So in this aircraft state sensors, different components are there. First one is air data system, ground quantity, air data quantity, that is attitude, calibrated airspeed, vertical airspeed, and true airspeed. So these are all the different airspeed systems which all these systems have been incorporated into a aircraft state sensor systems. The next one, navigation. So navigation in the sense for identification part of purpose. The navigation for accurate navigational information such as aircraft position, ground speed, and track angle is most essential for the aircraft mission. So here the navigation can be broadly classified into some of the types, that is DR system, data recurring systems, then position fixing system, radio navigation systems. So these are all the various navigation systems parts have been incorporated. Then next one is external world sensors. So external world sensors, the name itself, we can use it for to target detection, that is IR sensors, FLIR, forward looking infrared, then LIDAR, LIDAR, similarly radar, RADAR, radio detection and ranging, light detection and ranging systems. So these are all the parts which constitute for the external world sensors. The last one, task automation system. So task automation system generally involves the housekeeping management system, then navigation system management, then autopilot system management, then FMS, that is flight management system concept, then ECM, engine control and management system. So these are all the various categories incorporated into the task management system. So regarding the displays plays a very important part. Display is a most important one for the pilot to drive the aircraft. So displays in the sense several varieties of that, as we have already seen. So commonly used displays are LED, CRT, as you all know, cathode ray tube. Then specific displays such as head-up display, HUD, head-up display, helmet-mounted display, that is HMD, helmet-mounted display, and head-down display, that is HDD. So these are all the commonly used displays for the pilot line of sight propagation system views. So every pilot has to overcome all the difficulties through these displays. So display plays a very important role. So data bus, as we all know, for transmission and receiving of the bus systems. So these are the general block diagram of the avionics system. Now let us see about the design approaches. So design approaches, what is the function of design approaches? Basically it involves design, development and management of the total system, which includes hardware and software as well as other system life cycle elements. There are two major types of design approaches here you are seeing. First one is the top-down design approach and bottom-up design approach. So let us see the design procedure for the top-down. So hope you are seeing the design conceptual procedure. Concept, definition, design, build, test, and operate. So what it says, in order to generate the ideas, creativity, and various schemes, these are the process which covered for this design procedures. Then definition, to find out the abstract as well as analysis and decision making. Similarly, for design specifications such as drawing, calculations, and the software analytical part. So all these things has been incorporated in the design part. Then build, to develop or to construct a prototype or a design element. Then testing purposes, in order to test the articles and other things to find out the result and operate transit line problem solving areas. So these are the different design procedures to be carried out for the top-down design approaches. This is a similar model in which from top to down operational requirements, various required operational requirements are the system design, then development of a component, and finally integration, which integrates all those things in order to form a single part. So some steps for the design procedures: developing a conceptual view of a particular system, then establishing the different system architectures, then identifying the data streams and other data sources of information, then decomposing high-level function to its subfunction, establishing the relationship and interaction among the components, developing concept data representation, specifying procedure details. So these are all the various top-down design procedures in which the design approach part has been carried out. Now let us see about bottom-up design process. So performance assessment, integration, adaptation, existing components. So these are all the various design approach part for the bottom-up. So here are some of the points to be noted. Based on the reusing of the existing components according to the self-conceptual type. Similarly, it is a cost-oriented. So reduced development effort. The particular development of this product is somewhat low. Technical risk program, time schedule. It can be easily adapted to different platforms. These are some of the bottom-up design approaches part. Okay. Now let us see the general advanced trends in the avionics system. One of the biggest drivers for new generation data bus technology is the transmission of video, images, and other visual information such as terrain awareness and mapping as well as weather radar, generally which requires large increases in data quantity and refresh rates. The next one, these manufacturers of systems that addresses high bandwidth data bus networking face a number of challenges, threats. So these include maintaining the reliability and robustness proven in lower bandwidth networking technology, while at the same time it's keeping the cost and power requirements in the same range. Apart from this, in addition, these higher bandwidth applications typically generate more data and put pressure on downstream technologies such as storage and of aircraft data links, which have to be operated normally at a high speed. Another challenge relates to the cost and viability of trying to route new high-speed data buses to multiple points within the aircraft. Both military and commercial environments are typically noisy and rife, with various types of interference that may cause dramatic effects on the integrity of the data and the network system. So this ensuring a high degree of integrity and determination must be built into the network design from the ground up. Okay, hope you all understand all those things. So thanks for watching it. Thank you.